Here we are with our very last video on probability. Hopefully by the time we go around to week 6, I will be feeling better again. This is not just a hypothetical question about binomial distribution. In fact, asking, is special education placement independent of race? This is something when I lived in North Dakota years ago, I was actually called, along with Dave Gipp, who was president of United Tribes at the time, to give testimony before a congressional committee. So let's take an example. District A has 540 students. 10% of the students are in special education. 30% of students are Native American. If you remember the earlier discussion of independent probabilities, if race and special education are independent, then 0.1 times 0.3 times 540 of those students should be Native American in special education, or 16.2 students. So we should get 16 or 17 students in special ed if it's independent. Keep that in mind. District A is 540 students, 10% are in special ed, 30% are Native American. We ought to be finding 16.2, 0.1 times 0.3 times 540 should be Native American. Now, what if your district has 20 students in special education? It's more than 16, it's more than 17. The probability of this happening is 0.0606, or about 6.1% if we round it, right? And I just did equals binom.dist, like we talked about in the last video. 20, that is the number of students in special education. 54 is the total number. So that's 20 is the number of Native American students, the successes. 54 is the total number of trials. We pulled out 54 kids. And the probability of a student being Native American is 0.3. And I don't want to know what's the probability of there being 20 or fewer. That's why I put false. I want to know what's the probability of 20 of those kids. And this is when you go to these kind of hearings, you walk in the room and half the people hate you, right? Because they're on the other side. Well, Dr. DeMars, what is the probability that 20 of these students would be Native American? Then the school superintendent comes in and he says the probability of 20 of those students being Native American is over 15%. And he's not lying. So how can both 6.1% and over 15% be correct? Sounds like somebody's lying, right? Well, not exactly. One answer includes cumulative probability, and nobody's lying. The binomial probability of exactly 20 students is 0.0606, or 6.1%. The binomial probability of 19 or less is 0.84, because it's the probability of 19, 18, 17. So the probability, we go back to the probability of not A is 1 minus A. So if the probability of 19 or less is 0.84, then 1 minus the probability of 19 or less is the probability of 20 or more, right? Because you have 19 or less, or you have 20 or more. The binomial probability of 20 or more is 0.16, or 16%. The binomial probability of exactly 20 is 0.06, or 6.1%, if you want to be touchy about it. And to get this, as you saw in the last video, you put equals binom.dist, and then Excel will prompt you with the values to enter. And in this case, if I enter 20, there are 20 students total selected who are Native American. There were 54 students total, all told, in special ed. The probability, based on the number of Native American students in the district, was 0.3, and false. I want exactly 20. The probability of exactly 20, I get 0.06. If I ask, what's the probability of getting 19 Native American students or fewer out of 54, where there's a 30% probability of student being Native American, and true, I want it to be cumulative. So 19 or fewer, then that probability is 0.84. And 1 minus that probability is 0.16. And in this case, I would have to say I kind of agree with the superintendent, because yeah, the probability of getting exactly 20 is 6%, but the probability of getting 20, 21, 22, 23, um, all the way up to 54 is uh, is 16%. Now, that often, though, isn't the case. You often have a lot more than 20. So let's just take another example. Let's go back to Excel here. So this is our first example, right, where we had 540 students, point to 30% Native American, 54 trials, 54 kids placed in special ed, and 20 successes being that children were Native American. Let's say we didn't have 20, we had 25. Let's do our same analysis equals I know dot dist. And I want to know what's the probability of 25 or more. So I'm going to do 26, right, out of 54, probability of 0.3, and true. And it tells me that that 99.838% of the time, the probability of getting 26 or fewer is 0.99838, so on. The probability of getting 25 or more would be 1 minus that. And 1 minus that comes out to 0.0016. In other words, less than 1% of the time, 0.2% of the time, would you get a number this large of Native American students in special ed of 25 or more if it was truly independent of race. And those were the kind of numbers we were seeing back 35 years ago. In this case, then, the binomial probability really does have a practical impact where we're saying, look, the probability of you getting fewer than this number is 0.998, 998 times out of 1,000. You're going to get less kids who are Native American in special ed than this if it truly is independent of race. Do I believe that it's truly independent and this was just one of those 2 times out of 1,000 that happened? No, this was a long time ago, but you could actually get current data from North Dakota, South Dakota, from a school district and test this out for yourself.